In this video, we're going to look at a quick example of the derivative function and how the derivative function is related to tangent lines. And in general, you could have some function y equal f of x given to you. And there could be some point that you're interested in, x is equal to x0, also called a, and this could also be given to you, right? And what we would be looking at in that case is some function, okay, y equal f of x. Here's my some function. Value x is equal to a was what was given to you as some point of interest. And then we talked about the concept of a tangent line, okay, in class. And we know that the slope of that line, this line, is given by f prime of x, which you can compute using a limit problem. Okay? So I'd like to look at this problem and a specific example, and then just to recall one other important idea, that the point slope form of a line, is y minus y1 is equal to m times x minus x1. And this is how you would write the line in pre-calculus. Right? But in calculus, we know that our point of interest right here is the point of interest. This is what we're going to call a. And the y1 value, since we have a function, is going to be the function evaluated at a. So in calculus, we would write y minus the function evaluated at a is equal to the slope times x minus a. And we also know in calculus that this is our slope. That in calculus we know that this is f prime of a, where f prime of a, evaluated at a, is the derivative of the function f of x at the point of interest x is equal to a. So here is the equation of the tangent line that we're going to use in calculus. Okay? Right here, y is equal to the function evaluated at a plus the derivative times the quantity x minus a. Okay? So let's go through an example here, and and if, for example, the function f of x is, say, negative x squared plus 2x, okay? And we're interested in the point of interest, let's say 1, okay? And the question asks you to find the equation of the tangent line. To find the equation of the tangent line, you're going to need the function evaluated at 1. You're going to need the derivative evaluated at 1. And the way I'm going to get the derivative evaluated at 1 is to first find the derivative function, and then I'm going to find the derivative function at x is equal to 1. And then we're going to use the equation that's given in the box star. Okay? So, if we're going to compute the derivative function, f prime of x, we need the slope of the tangent line at any point, at any value x, so limit as h goes to 0, f of x plus h minus f of x divided by h. Okay, need to compute a limit. F of x plus h is negative x plus h squared plus 2 times x plus h. Then I need to subtract off the function value again, and I need to divide all that by h. Okay, so we have a limit to compute. That's the last step. We'll go ahead and FOIL everything out. I'll get negative x squared plus 2xh plus h squared. Distribute the 2, and then distribute the minus sign. Okay. And we can see here that the x squareds are going to cancel out. There's a minus sign there. We'll have left minus 2xh on this term. We'll have left a minus h squared. The 2x's cancel out, and you're also left with 2h. Okay. And then remembering that we also have to divide this whole thing by h. So we also have a divided by h left. Okay. Limit as h goes to 0. And we do have to factor first, because we can't look at h goes to 0 because we have a division by 0. So if you factor out an h, the h's cancel, and when you compute that limit, you will get negative 2x plus 2, which is what we called f prime of x, the derivative of this function at any point. Okay? So, I now know that we have a function at the page below. We had a function f of x was negative x squared plus 2x. We had a point that we were interested in, which was called a is equal to 1. It's an x value. And then we found that f prime of x, using a limit, that the derivative at any point x is equal to negative 2x plus 2. That's what we found. So now we can take our derivative at any point and find f prime of x at any value that we want to get negative 2 times 1 plus 2, which will be 0. Okay? And therefore, the equation of the tangent line that we had in the other box was y is equal to the function evaluated at a plus the derivative evaluated at a multiplied by the quantity x minus a. So we have the function evaluated at 1. The derivative evaluated at 1, we got 0 multiplied by x minus 1. The function evaluated at 1 is negative 1 plus 2. 0 times anything is 0. So y is equal to 1 is the equation of the tangent line. Okay? You could have repeated this process. Find the equation of tangent line now at some other value of x. X is equal to 2. Okay? You could have done the same thing. Y would be the function evaluated at 2. The derivative of the function evaluated at 2, x minus 2. And since we have the derivative function, there's no need to compute a limit anymore because we found the limit for all possible values of x. So technically all we need to do now here is take f prime of 2, which is negative 2x plus 2, and evaluate that at x equal 2. So the slope of our line at 2 is going to be negative 2 times 2 plus 2, which will be negative 2. That's the slope of the line at x is equal to 2. The value of the function at 2 is negative 4 plus 4, so the value of the function is 0, plus negative 2 times x minus 2. So the equation of the tangent line at a new point would be y is equal to negative 2 times x minus 2, or if you prefer, negative 2x plus 4. Okay? So there are two computational examples on how to use the derivative function, which can be found by computing a limit and using the derivative function to help you find the tangent line at 2 points. And that will end this short video.